Okay, let's talk about some stoichiometry. Okay, make sure that you're always using a balanced chemical reaction. Usually we're going to need to determine the limiting reactant and write down the species that are actually present in the solution. So sometimes there would be spectators or whatever that aren't contributing. Usually we're going to need to obtain moles of reactants, and because we're dealing with concentrations and molarity, we're going to need to use volume and molarity to find moles, just like we did in the previous section. Okay, here are some steps if that helps you. Identify the species present and determine what reaction occurs. So do the products, do the solubility, what we just talked about. Write the net ionic equation. Make sure it's balanced. Calculate the moles of reactants. Determine the limiting reactant. And then calculate the moles of product required. Now these are the general steps. You don't always have to follow all the steps. It kind of depends on the problem, but that's the general outline. Okay, and the sixth one is to convert to grams or other required units. Okay, so let's look at an example. So in aqueous solutions of Na2SO4, so while I'm reading this problem, I'm going to start writing my reaction. Okay, and lead 2 nitrate actually, and it's also aqueous, okay, are mixed, so I put them together. PbSO4 precipitates. Okay, so I know one of my products is going to be PbSO4, and I actually don't need to do the solubility on this. It tells me that it precipitates, but it's always good to check. And if you remember, one of the last rules was that all sulfates are insoluble unless they're mixed with group 1A metals. Lead's a transition metal, so it is indeed insoluble. Now it says calculate the mass of PbSO4 formed, so we're looking for grams, question mark, formed when 1.25 liters of 0.05 molar PbNO3, so 1.25 liters, and it's 0.0500 molar. I like to write all my information underneath the reactants and products that are involved. It makes everything a bit more streamlined. It's easy to find what you need. Okay, and then we have 2 liters of 0.0250 molar Na2SO4. Okay, and we want to know grams of lead sulfate. Well, we are indeed going to need to find the limiting reactant because we've got information about both reactants. But first, let's finish our chemical equation and write our second product. So lead and sulfate already went together, so that leaves us with sodium and nitrate, which are +1, -1, and we know anything mixed with nitrate is aqueous. Okay, we should probably also check and make sure that it's balanced. I see that we've got 2 nitrates, so I know I needed 2 out front. That gives me 2 sodiums, which I already have over here, so now it's balanced. Well, let's look at the species of interest. We've got our 2 reactants and the lead sulfate. Well, if you forgot about the sodium nitrate for a second, everything else is 1 to 1 to 1. So if I find out the number of moles of each reactant present, it should be pretty easy to find the limiting reactant. So in order to do that, I know molarity is equal to moles per liter, which means that moles is equal to molarity times liters. So if I take my liters times my molarity for Na2SO4, I've already done this for you. It's 0.05 moles. And if I do it for the lead 2 nitrate, I get 0.0625 moles. So if everything's 1 to 1 to 1, I'm looking for the reactant that's present in the least amount, because it's 1 to 1 to 1, it will get used up first, and that tells me that the Na2SO4 is my limiting reactant. So that also means that I now have 0.05 moles of lead 2 sulfate, because it's 1 to 1. So now that I have moles, it's a simple conversion to go to grams. So 0.05 moles of lead sulfate. Now, if you wanted to set up the whole limiting reactant problems and do the mole ratio, you could definitely do that. But when we're doing these problems, we're really trying to save time and be economical with our time. And because everything is 1 to 1 to 1, it's a very simple calculation. Okay, so we have 0.05 moles of lead sulfate. I know for every 1 mole. And I already figured out the molar mass. That's quite large considering it contains lead. 303.27 grams. And so if you multiply that by 0.05, you get 15.16 grams of lead 2 sulfate. Now let's look at our limiting reactant, our significant figures. If I look up into the problem, it looks like I have 3 And so my answer is 15.2 grams of lead to sulfate.